Alrighty, should be live-ish, and so I should be with you in a minute. Another Professor Dave video. We'll play one of his videos on what is a really profound subject, and yet it won't be a very profound video. So it's called Work and Energy, and it's 4 minutes or something like that. And it won't explain anything or use those words in any kind of rational way. Because that's not physics's mission. Reason and logic and consistency doesn't mean anything. And they're junk, garbage, stupid, moronic physics. So, almost there. Just gotta do this whole crap to be able to see the chat. I have to open a different window and all this nonsense because YouTube has broken my Draft Science channel, so I can't use it for anything. But anyway, just one of the minor inconveniences the evildoers impose. Yeah, it's just life on Earth. Alright, so I should be able to play now, reasonably. Alright, so so the video's titled Work and Energy, and it's not going to be about work and energy. I mean, it's not going to give you any insight into some sort of concept that there's this stuff in the universe called energy or force or even momentum, and that's all that there is. There's this MV. Okay, and you can move the MV into different things. So you can have a big M and a small v, or a big V and a small m, and basically it's a quantity of motion. It's a quantity of substance in terms of power or capacity to exchange. And that's all you're really saying is when you exchange it, you're going to call that work. And there's work you like, okay, the stuff that, say you throw a bowling ball. Obviously you lose some of your energy while the ball's sliding and rolling down the alley. It's leaving behind a little bit of its momentum. And so you did work on the alley. You banged it, when you dropped the ball. You did a pretty good little piece of work, especially the way I used to bowl as a kid. And sliding, and it's applying pressure, and it's affecting the alley, and the alley is absorbing heat from the ball. It's just a fact, and the ball is losing some of its momentum. Now they use the word work and say, well, that's not work. Well, it's only work if they intended it to be work. if they intend to accomplish the task, then they call it work. So it doesn't make any sense. It's all exchanges. And so they're basically just saying work means exchanges we like, and exchanges we don't want, we'll call that something else. And it's just idiotic, because it's the same thing. So there's like hammering a nail. You have the part you don't want, which is all this terrible friction that creates a ton of heat, and it just makes getting the nail into the wood harder. Right? And so that's the work is, well, I've got the nail 3 inches into the wood. But most of the work you did wasn't getting the nail to 3 inches in the wood. Most of the work was, heating the wood and the nail. Alright, so with that preface, that's probably good enough. Let's play some of this crap. And it's just steaming crap. I'm going to probably interrupt a lot.
Professor Dave here. Let's learn about work and energy.
So that's not going to happen. You're not going to learn anything. You're just going to be told that there's some formula or some idea or some concept that reliably does something, and it doesn't. Because, as I've pointed out, and I can point out again in this video, friction is variable. So you can never have a coefficient of friction, and there's never a circumstance you'll ever be able to create where that coefficient isn't constantly changing. So it's almost a useless idea, because no matter what you're pushing, you're going to change speeds, and as you change speeds, you change friction. biggest friction is it? In just about any case, it's time dependent. How much time are you being pushed into something? And with what force? So even if you can find a constant force, which is really hard to do, if your speed is variable, the friction's variable.
He knows a lot about the science.
So he really doesn't know shit. He just knows how to read a Wikipedia page, pre-process the information into Grammarly or whatever, and make a new spiel that's the same spiel with just different words.
Stuff Professor Dave explains.
And explains what? Explains absolute gibberish. There's just gibberish in this video. It's not going to get you any understanding of the concept of what energy is, because frankly, you have to go back to the 1600s and recognize that it's a quantity. It's a substance that things actually possess, and that they exchange that substance. The bowling ball essentially has heat going in one direction. That's how you could, you want to understand, you want me somebody to explain it. Well, this is how to explain it. It's basically heat all going in one direction. And you can lose that quantity to the environment. You can give it away and make the environment move in all kinds of different directions. Obviously, the energy, the heat, is easy to see when it's in a big object moving in one direction, and it's really hard to see when it's in a million little directions going all kinds of places in tiny amounts. That's the difference. One is easy to see, one is hard to see. That's a reasonable explanation. There's energy that's really easy to see, force, really easy to see, and force that's really hard to see, because it's made out of its elemental discrete elements. The more elemental it is, the more discrete it is. The tinier the object it's pushing, the harder it is to see. Duh.
Just like force, the words work and energy have a variety of connotations in common.
So what's the point? Then it's not science, it's something else. No, it's not really not science. If the words can't mean one thing, be explicitly defined, what science could you possibly do with a word that means, well, it means 4 or it means 7. Sometimes it means 11. No, that doesn't work. You can't, that doesn't work. That's not reasonable or coherent or scientific. That's the whole reason why science has all these formulas and all this explicitness, is because it needs to be exact. Mushy terminology is not scientific.
Common language. When we say work, sometimes we mean exercise.
Well, obviously that's not this context, but obviously when we say work, we're really saying I'm going to exchange. Okay, so we go to work, it's exchanging your time and your energy, frankly. You're going to have to give away the calories.
Other times we mean a place we go every day and do something to earn money. Energy is even more convoluted. We might say that today we have no energy, meaning we feel tired. Or we might use the term in a...
So those are perfectly consistent, frankly, with the concept of either being full or empty. So that makes some sense. But that's not the problem here. The problem is that you don't understand that energy is momentum, is force, is pressure, is weight, is heat. That all of it is energy.
Completely metaphorical way, saying that a person or a location has good energy. But once again, in physics, these words mean something very specific. And if we are to learn
So that's the big lie. It's not anything specific. They claim it means something, and it doesn't mean it because it doesn't happen. 25 times the fuel to go 5 times as fast, for example. It doesn't happen.
Science, we must allow the rigorous definitions to replace the colloquial connotations.
So we waste a minute of the video on that crap. So now we're down to 3 minutes and 56 seconds of science.
Work is defined as action done on an object.
Okay, so this means that all exchanges are work. So again, you can't play this game that, well, the only work I'm going to count is the work I can see. You know, if I can't see it going up and down, it's not going up and down. Well, that's bullshit. You know, and again, if it's half of it's going up and the other half is going down, well, what's the displacement? How could I possibly calculate the displacement when the parts are moving in opposite directions? The whole object isn't moving. So it's just bullshit. Displacement is irrelevant anyway. So that's what so let's just do the most classic displacement drawing, okay, which I have done over and over, but it's just such overtly true physics, and it just totally annihilates any notion that kinetic energy has anything to do with reality, or that their silly equations have anything to do with reality. I mean, it ends the subject, so to speak. There's no subject. Where the hell is the any? That's the one I gotta get rid of. Okay. All right. So if I throw things in space with one velocity and I throw something else with two velocity, obviously the thing with two velocity isn't going to show itself to have 4 times the energy in the sense of its distance. So the distance it travels is going to be exactly twice. So we know that's an absolute fact. So because we're not collecting its energy, right? So I mean, so it's not a test because we're not really collecting the energy, right? So I can't put it up there. It's too far over anyway. Okay, good. All right, so I have 2 objects. So one's going to go twice the velocity of the other one. 2v. All right. So obviously, I'm just saying, we know that if I do this distance crap, you know, if I just measure how far they travel, obviously in the same unit of time, they're going to travel exactly, one's going to be exactly half the distance traveled. So it's not debatable. So the distance is going to basically say there's no kinetic energy, obviously. But again, we're not collecting anything. So we're not measuring how much kinetic energy there is. So if we change the scenario just very slightly and roll the objects. And so now we're going to use friction to collect all the energy, pull all the energy out. We're going to do work by his definition. Action done on an object that displaces the object. Well, technically, the ground is going to be displaced. But I mean, you have to be able to understand that the only place the energy is going is from the object into the ground. The movement is going, the object will start moving less, and the ground is going to start moving more. I mean, I shouldn't have to explain that to a physicist, right? But, I mean, that's the absolute true physics. And the absolute true physics is, yeah, the object going twice as fast is actually going to roll 4 times as far. Maybe 5, frankly. But what's really happening? I mean, why is it doing that? So again, as pointed out, we already know what 1 velocity looks like, and we know the thing going 2 velocity will eventually go 1 velocity. So we know that 1 velocity is going to be here. So it's going to be going 1 velocity 3/4 of the way down the track. Because we know this experiment will be exactly the same as this experiment. And so all we have to do is figure out, well, what's this about, this 3 units of distance here? And it's the same thing when you're dropping something in gravity. 1, 3, 5, 7. So the same distance thing shows up. So it's sort of obviously saying to you, well, this is the same as gravity. Friction is being completely controlled by gravity in this case. So it's applying a constant force in the downward direction. And the key is this is 1 unit of time. This will take 1 unit of time. And this whole thing will be 1 unit of time. So I'm only going to get 9.8 meters of pressure. Let's just call it pressure. 9.8 units of pressure. And there's only 9.8 units of pressure applied in that second. And there's only 9.8 meters of pressure applied in that second. So you know that the pressure being applied is now being per square inch, is a lot less. It's 1/3 of the pressure being applied here on average. Now the actual pressure actually starts at the highest speed there's very little, and at the slowest speed there's a great deal. So your friction area looks something like that. The friction is increasing as the velocity decreases. So there's no, if you're going to use a constant for friction or something, obviously that's not going to work because it's not a constant value. The friction's constantly changing as your velocity changes. The amount of pressure being applied, the thing pushing you into the sandpaper, is changing. And as it changes, as it gets slower, it gets higher pressure. As it's faster, it's less pressure, so you're making less of an exchange. So all that's really happening in the experiment is yes, the object has the motion, and then the ground has all the motion. And in this case, the object has all the motion, and then the ground gets all of the motion. It's just a transfer. So you did work on the ground, and the fact is you only did 2 units. So twice the velocity is only twice the heat. There's only twice the heat in the ground. Okay, this ground is only twice as hot as this ground because it's only twice the amount of time being pressure being applied against your motion. And that's all that matters, is the amount of time. And obviously the distance, you were getting a free ride through here, and then you had to work really hard for that last bit. Was really expensive in terms of you gave away a lot of your money when you're going 1V, and you gave a lot less away per second, per unit of distance in the beginning. Now, I don't think there can't be a rational counter argument that says that's not true. So they're saying it went 4 times the distance. Their formula says 4 times the distance, 4 times the work. Well, it's obviously not 4 times the work. It only took 2 seconds, and the only thing making you do the work is the force pushing you into the sandpaper, so it can't be more work. Just 2 units of work. It was only 2 units of energy. There's no 4 anywhere. Okay. And again, it gets worse and worse as you increase a 1 to 3 mass. They're saying it does 9 times the work. It just gets sillier and sillier. And I illustrate it by pointing out 25 times the fuel to go 5 times the velocity. And that never happens. There's no experiment showing that to be true. That's what their physics says. That's the explicit statement of their physics. And it's demonstrated to be wrong in every case. Rockets don't obey the kinetic energy formula. Levers don't obey the kinetic energy formula. Ballistic pendulums don't obey the kinetic energy formula. Collisions don't obey the kinetic energy formula. Water doesn't obey the kinetic energy formula. Nothing obeys this idiotic formula. So we don't even know, in this video, he's not going to tell us what he means by energy. Obviously, they mean kinetic energy. They mean some nonsense about an mv squared that doesn't happen anywhere, that isn't real. It was only invented because a moron thought that it's the distance you fall in gravity is how much energy you get. So if you fall 3 units of distance, even if it only took, 9 units of distance, even though it only took 3 seconds, 3 units of time, somehow you collected 9 units of energy, when obviously most of your velocity was already acquired velocity. And you weren't acquiring any force as you covered those distances. So you don't acquire energy in units of distance. You acquire it in units of time.
Whereby an applied force causes a displacement of that object. A basic example would involve pushing a box 10 meters across the floor.
So that's a silly example in the sense that you really should use examples where there's no friction, because again, friction is completely variable. It depends what the box is made out of, depends on what the floor is made out of, and it depends on how fast you're pushing the box. what speed the box is moving.
Work is equal to the magnitude of the applied force.
So this is the bullshit. It's never times distance. It's just never true in the sense of any real experiment with real applied forces. So in the case of gravity, it is true that you can just do force times distance, okay, and as long as you understand that it's quadratic, that is, it's going to be the square root of that answer. But that's the only way it works. The distance is a symptom. It isn't the cause. The cause is a time-dependent force, 9.8 meters of extra velocity, meters per second, per 1 second, by the way, per 1 second.
Times the displacement of the object. So it has units of force times distance. If you push with a constant force of 100 newtons over...
So we know that nothing can really do this constant force pushing thing. It's really hard to do. So I'm just saying no human could ever do that. It's impossible to apply a constant force, especially when something starts moving. Then the force gets all out of whack. So that never happens. And again, your force is against some mechanism that you're doing work on. And depending on, like I said, depends on whether it's sandpaper or it's glass with oil on it. It depends on what the surface is. So they're best understood as arguments in space. And if you do these arguments in space, it'll be very unconfusing because the distance will tell you how fast you're really going. Twice the speed will be twice the distance. It won't be 4 times the distance.
Over the 10-meter distance, you would do 1,000 Newton meters of work, which are equivalent to another SI unit called joules.
Right. So he's just demonstrating, too, where people say, Newtons aren't joules. Well, he just said it is. So, again, just more of their nonsense game-playing bullshit. So they keep saying, a Newton is a weight, and joule is a measurement of energy. Well, he just told you that, no, it's the same thing. You just convert one right into the other. So let's not pretend a weight isn't joules. Everything's joules.
This means that work can only be done when displacement occurs.
So again, it's not about the displacement. It's about whether you created heat or you stored chemical energy in atoms, you compressed electrons. There's all kinds of ways that you convert the MV into a new MV. And it doesn't have to be in some way that you can see. So again, this whole displacement argument is idiotic. You can see it in Newton's cradle. There's no displacements. There's no accelerations in the Newton's cradle. The force goes right through one, and at the speed of sound, flies out in the next one. So it just goes right through. It just travels right into the object. There's no, I have to decelerate one and then accelerate the other. None of that ever happens.
If you push a brick wall with the same force for the same amount of time as the box, you may get very tired, but technically you have done zero work.
Right, so this is silly, right? So you know you did work, depending on, again, what the wall's made out of, right? So if the wall does move just a little, well, then you did the work of, causing some kind of vibration in the wall. You did work in the sense that whatever you're applying the force with, you compressed it, you rubbed it, you created heat. So there's all kinds of evidence of work that way. But the real statement is what you did was work on the foundation. The work went into the ground as pressure. So you applied pressure to the ground. You essentially have a lever. If I have a pole and I push on it, you can understand that even if the pole doesn't observably move, that I have put a whole bunch of pressure on the fulcrum of that pole, and that I have in all likelihood displaced matter inside the earth. And such. Hit the button. Oh, let's put the video back up. Sorry, not that you're missing anything.
In addition, only the components of the applied force that are parallel to the displacement are considered to be contributing to work.
So again, parallel to this displacement just means the objective of making it go this way. Well, the fact is those aren't the transfers you're going to make for friction and heat. Those transfers are going to be more likely. Say there's an electron moving inside of an atom and I push on it. Well, it could have been going this way. The electron could have been going that way. And what I'm going to basically do is create a new vector. You know, I shoot a bullet into an object. The slower I shoot the bullet, that is, the lower the velocity into clay or gel, the more displacement I'm going to get. That is, the more likely I'm going to have the vectors combine. The motion of the atoms and the motion of the bullet are going to combine and create some kind of tangential direction. So if I go really fast, then all the energy stays going this way. But if I have, as I lower the speed through a medium, I'm going to share my momentum more, and I'm going to create more scatter. And so it's basically saying anything that isn't in the direction of the bullet, they don't count as work, when obviously it's work. Just like vibrating the alley with your bowling ball is work. It comes out of your ball. Your ball loses MV. The floor gains MV. Fact. Absolute fact. All right, we do have a comment. I asked ChatGPT. Well, there's no, there's nothing. You're not asking anything. It's like asking Professor Dave, because all it is a combination of what are called authoritative statements. So ChatGPT knows credible from incredible. I mean, it knows a flat earther from a degreed physicist. And so it just takes a bunch of opinions, puts them together and says, who wins? What's the majority opinion by my credible authorities? And then it just rewords it into Grammarly, and that's it. It's not thinking. All right. About what determines work done on an object, the time versus the distance. Time doesn't change the total work. So again, obviously silly. Okay, it only changes how much power you're using to do that work. So again, isn't that the silliest statement ever? Obviously, it has to be either a complete or a partial transfer, but you can't change conservation of energy and power. There has to be conservation of energy, or power, or work, or joules, or whatever you're talking about here. So the conservation laws have to be applied because their own physics says you have to. Richard Feynman goes to all this trouble talking about hidden blocks and how you have to always be able to find your blocks. You can't undo the existence of the energy. It always has to be accounted for. The force, the motion, the MV. So that statement's obviously fucking silly. Okay, so no further comment needed there. All right, continuing.
If you push the box with your arms parallel to the floor, all of your effort contributes to work done on the box.
Well, we know that all of your effort doesn't, right? Because you're losing energy to friction with the ground. So, that you're stepping on to be able to apply your pressure. So whatever your total pressure is, it's not going to be just your motion. So unless you shoot me out of a cannon without an atmosphere and have me get stuck completely to the object, that's the only way you can say your total energy is being transferred, because otherwise there's always losses to the environment. You're going to do transfers before you get to do your transfer. Okay, before you even get to your transfer, you're going to be transferring.
But if you are pushing at a downward angle, only the x component contributes to work.
So again, it's just more nonsense, but obviously in space that will work perfectly, okay, just because there's no friction coefficient. So you get rid of the friction coefficient, it becomes a pretty simple equation. But it doesn't have anything to do with kinetic, obviously, energy. So you don't, it's just a transfer of momentum. All you can ever transfer is momentum. So I'm just saying the transfer is already written in stone. That's Newton's third law. You can't undo that mechanism. If I hit the spaceship with some little object, a BB, and it has 5 million joules of kinetic energy, but it only has 50 joules of momentum, the only thing the spaceship will collect is the momentum. It won't collect anything else. It can't collect one tiny joule more than just the momentum. And those are absolute facts. That's an absolute fact, that none of the kinetic energy will do work on the spaceship. None of it. Except the 50 joules of momentum.
While the y component does not. In such a scenario, instead of using W equals Fd, we could calculate the work done on the box using W equals Fd cosine theta.
And it doesn't mean anything without the friction coefficient. So again, it just doesn't mean anything in a real world circumstance because it all depends on what the box is made out of and what the floor is made out of.
As this will give us the portion of the applied force that is operating in the horizontal direction. If theta is 0, meaning the applied force is horizontal, cosine theta will be equal to 1, leaving us with W equals Fd. And if you were to push straight down on the box, theta will be 90 and cosine theta will be 0, meaning no work is done on the box and it will not move.
Right, so this is just silly again. Obviously, as you're applying weight, it will move because right now I'm moving the Earth, okay? Whether I like it or not, my weight is part of the weight that's sitting on top of the center of the Earth's head. And it feels it all. You keep adding weight, it knows you're adding more weight because the pressure increases. So it's just an absolute fact that all this weight is stacked. And everything under the stack feels any added weight on the top. So obviously the pressure is getting into the Earth, and it obviously is doing Earth work in the sense that it's going to heat the Earth. Just so it's an absolute fact that every rock on the Earth is heating the Earth. It's just a fact. It's doing work. And the only way it has power to do work is gravity did work on it first. Gravity's doing work on me. I'm doing work on the ground. The ground's doing work on the center of the Earth. That's how it really works, Dave.
Any angle in between, and there will be some motion. We must bear in mind that work is a scalar.
So this is the real baby talk, okay, where they invent some notion of a scalar, whatever the hell that could possibly be. So it doesn't work, it doesn't happen, the kinetic energy will never be transferred. So in none of these experiments, ballistic pendulum, water wheels, turbines, drills, no matter what I use, I will never transfer the kinetic energy. So kinetic energy in, no kinetic energy out. All I'll transfer is the momentum. So that's the absolute truth. Momentum is the only thing you can transfer. You can just transfer big M's and little V's and convert them into little masses and big V's. And that's it. You can't do anything else. And vice versa, of course. That's it. There's no scalar, though. There's no definition for whatever this frickin' weirdo, silly crap word is. There's no such thing. Now, you could argue that heat is dispersive. So you could say it's multidirectional by tendency. And so you could say dispersive. Okay, the energy is dispersive. It's, has more than one direction. But it's always vectors. The individual pieces of energy are moving vectors. They're not moving scalars. They're moving in linear motion. All right, we have a couple of comments. Let's see what we got. If I held a 50-pound weight for an hour versus a minute, the time matters here. Yeah, duh. Exactly my point. Yet conventional physics says the time doesn't matter. Right? Well, it's just they're playing a word game. They know you did more work. They're just saying somehow we have this physics notion that says it's not work unless we can see it. And again, you could argue that if you took a slow motion camera and actually watched the person holding the weight, you'd probably see all of this, all of this jitter. So you'd argue, oh, wait a minute, they are doing work. It's positive, negative, positive, negative, positive, negative, positive, negative, right? But it's a lot of work. It's, no doubt about it. So it's just baby talk in the sense that, I mean, obviously we know it's not about what we can see with our eyes. It's what we can see with our minds. It's what we can see with our models. That's what we're showing. That's the thing we should be talking about, is what does the model say is happening? Because the model tells you the truth. And you know that you are doing more work because you're constantly fighting a force that's pushing down, and that you have to absorb that force and push it into the earth. And in that process, there's a whole bunch of friction that you're going to get heated by. Oh, another chatbot statement. Okay, chatbot says, biological perspective, your body does expend energy holding a weight, but that's because of muscle physiology. Well, no doubt. Not because of additional work in the physical sense. Well, obviously that's it. That's just showing how the failure of chats, these AIs, is it's a perfectly reasonable written sentence, but it obviously is contradicting itself. Okay, so it's obviously saying, well, yeah, no, you have to use your muscles, but somehow it's not really using your muscles. I mean, that would be just idiotic to say, right? You didn't use your muscles when you used your muscles. So it just said something really stupid, and it's just too stupid to know it just said something really stupid. All right, 5 times the velocity doesn't take 25 the energy according to the KE formula. That's just an absolute lie. So I'm sorry, Scott, but you're a liar. Okay, that's the absolute demand of the formula. It demands it to be true. It demands it. So you're just a fucking liar. KE says it takes 12 times the energy. Still wrong. It takes 5 times. So I'm not going to argue with you. The explicit formula says it's a quadratic increase. If you go 3 velocity, it's 9 units of force needed. If you're going 4 times the velocity, it is 16 units of force. To go 1 velocity, you use 1 unit of force. It's obviously, if it's 25 times, then it's 24 extra units of force. So fuck you, you lying piece of shit. All right. KE doesn't say 3 times the velocity takes 9 times the energy. I'm not going to argue with you, so I just block you, time out you. This is just crap. KE says it takes 4.5 times the energy. It's not right. Sorry, that's not what it explicitly says. So you're wrong. Okay, it explicitly says this is how many units of energy you need. So you're just playing word games. All right. So let's see what this other... Let's savor est some kind of bullshit, some foreign language crap. But the thing is that the professor is giving the silly explanation told to high schoolers, but I know in university, so don't tell me it's not in university. I've watched all the lectures. Professor Lewin says the same horse shit. Exactly the same horse shit. We don't give the same explanation as high schoolers, but there are a lot of mistakes. So why don't you just give me a link, okay, please? If you can't link in this stupid chat, send me an email, ds@donotgo.com. Send me an email, give me a link to where a professor is explaining it some other way than this asshole. They say exactly the same crap, that somehow kinetic energy is a scalar, whatever the fuck that could mean. It's linear motion, but it's a scalar. It's a train going down a train track, but somehow it's not going in a linear straight line in one direction. It's somehow scalaring, whatever the fuck scalaring is. I mean, it's ridiculously silly. All right. Same is not a Professor Dave. Same. What the hell? I mean, my eyes are really bad, but what the hell does that say? Same. Not a Professor Dave. I don't know what that means. I suppose you can be a professor by job description. I don't know. I don't know whether there's, does professor mean doctorate, or does professor mean PhD, or does it mean, what's the other standard, master's? I bet if you used an infrared camera, you would see the heat build up from holding for 1 hour in comparison to a minute. Yeah, well, that experiment's actually already been done. So I think even Thunderfoot did that. He rode on an exercise bicycle, just so he could show off his body or some kind of crap like that, right? And you could see his sweaty armpits, changing color, all of that shit. So yes, it was really quite disgusting, actually. All right, 1/2 mv squared equals ke. Why forget about the half? Well, because the half is just a constant, and it doesn't really matter. It's for the fact of creating units. So, do we really give a shit? We're just saying it's a unit of energy. If I just say it's one velocity, 1 unit of velocity, does it matter what the unit is? Whether it's a mole or a, cubic meter or, a spoonful. It doesn't make any difference? No, it doesn't make any difference. We're just comparing quantities. We're just saying how many quantities, how many quantums, how many clumps of the substance do you need to do something. And that's all it is. So why bother with the half? Not that I'm opposed, I'm just saying why bother? Alright, so back to the video, I guess. We'll let a couple collect. So now Scott says 1/2 of 25 is 12.5. It doesn't matter. We're talking about units of energy. So that means your first unit has to be 0.5. So to go one velocity, I use 0.5 joules, let's say. Isn't 12.5 25 times 0.5? Isn't it? Jesus, see, you're just playing games, all right? You play another game, I'll just time out you, because you're just playing a game there. Obviously, if I apply the half to the 1 unit of velocity, it would be 0.5. Jeez, you're just such a cheater. So this is what I have to do. I have to catch your little cheats. The little cheats you're going to do. You're going to just type a bunch of little cheats, and then I have to do the detective work to figure out, oh, okay, I see what you did there. Per second. Even though it's 9.8 meters per second of velocity, and that means per 1 second. So it's 9.8 meters per 1 second over 1 fucking second. Not second squared. It's not 1 second squared. It's 1 second. The 9.08 meters is only true if it's 1 second. If I make it 2 seconds or 10 seconds or 15 seconds, I have to change the 9.8, jackass. So are those the kind of games you're going to play? Let's see what he says. That's the formula. Okay, fuck you. No, I'm not even going to time out you, because I know what the fucking formula is, asshole. And I just explained how if you're going to use the 1/2, okay, you have to apply it to the 1 unit of fucking goddamn velocity, and that means it's 0.5. And 12.5 is 25 times 0.5. Fucker! God, these people are so fucking dishonest. Oh, just god damn it. These people are just such garbage. Future, hunt the fuckers down. These people are a menace to civilization. These clocks stopping, let's stop anybody from talking the truth, and let's do it with lies and convolutions. I mean, I out his trick, and then he just says, no, it's a perfectly valid trick. No, it isn't. Uh-oh. Firefox just crashed. Game over, Gary. Interesting. I wonder if I'm still... Nope, I'm probably dead. Yeah, I don't know. We'll have to find out. Looks like I'm dead. Anyway, Firefox crashed. So I guess you can't know that until I let you know that. Excellent connection. Let's see. So anyway, Firefox crashed, so I mean, the statistics all look okay, so maybe I'm back. Who knows? I'll check the chat and see if the chat, so somebody chats something, I guess, and that's where I'll find out whether it's still running, I guess. Let's see, where the hell's this old chat window? All right, so somebody, well, I guess I could chat something. Yeah, I don't know. So will that work? Something. Okay, let's see. It seems to have worked. So, okay, I'll leave it alone. We'll see what happens. So anyway, so I'm using Firefox and I have the chat in Chrome. So it's, yes, like I said, it's kind of complicated what I have to go through just to make things work. So I need to reload the video, I guess. Yeah, that seems to have gone. So I have to find that again, I think. Appears to be gone, yeah. Pop-up window disappeared, I guess. I don't see it. And I don't hear enough volume, and I can't pop out the window. Junk garbage, stupid. Oh, it's funny, I can't hear it now. I wonder what that's about. Sound shouldn't have changed. Alright, let's see. There's a pop-out window. Oh, that's the chat. Alright, is there anything else I can check? I guess not. So I guess I have to refresh this. You don't want to do it, but I have to. And I don't know what it's going to do through the chat, but whatever. Not my problem. Yeah, right. Okay, it destroyed it. Alright, so I have to pop it out. Okay, it destroyed it. Alright, and I have to turn that off. Yeah, that's me. Okay, yeah, that's not what I'm looking for. That's not what I'm looking for. Oh, it closed my damn private window. Okay, so that's why I'm fucked. Oh, so I have to go find the Professor Dave video again. Ew. Ew, I should have downloaded it, I guess. But whatever. I didn't. He's on this list somewhere. Professor Dave explains. Yeah, fuck him. Alright, and I have to go to his videos and type in energy. Guess that'll work. Ugh. Maybe I'll just type in work. There it is. Work and energy. Okay, then I click on that. Sorry for the delay.
Are you guys here for the halftime show?
Oh, no. We're here to help people customize and save with Liberty Mutual.
So that's why the emu is here?
Okay.
Professor Dave here. Let's learn about work and energy.
He knows a lot.
Brick wall with the same force for the same amount of to another SI unit called joules.
Yeah,
This means that work.
all right. Okay, so pop that out. At least that should be now. Yes, it's now visible. All right, it wasn't that bad. Let's see what the chat says. Ah, nothing. Oh, that's fine. I thought there was some new chatting, but I guess not. All right, so that's fine. All right. Sorry, it wasn't my fault. Probably wasn't. It was kind of coincidental, right, when I was really pissed off and the computer missed a sensed it. Yeah, I don't think it could do that. It's entangled, Gary. No, it isn't. No. Don't fall for that. Alright, anyway, let's play this shit. Garbage. Crap.
Work can only be done when displacement occurs. If you push a brick wall with the same force for the same amount of time as the box, you may get very tired, but technically you have done zero work.
So we know that that's just not true. You're doing all kinds of little work, okay, but that you can't see, but you're doing work, and your body's doing work to maintain the pressure.
In addition, only the components of the applied force that are parallel to the displacement are considered to be contributing to work. If you push the box with your arms parallel to the floor, all of your effort contributes to work done on the box. But if you...
So again, it just doesn't, all your effort will be decided by what friction there is. So again, it's just a bullshit example.
are pushing at a downward angle, only the x component contributes to work, while the y component does not. In such a scenario, instead of using W equals Fd, we could calculate the work done on the box using W equals Fd cosine theta, as this will give us the portion of the applied force that is operating in the horizontal direction.
So it just tells you the percentage of the energy that's in the same direction.
If theta is 0, meaning the applied force is horizontal, cosine theta will be equal to 1, leaving us with W equals Fd. And if you were to push straight down on the box, theta will be 90 and cosine theta will be 0, meaning no work is done on the box and it will not move. Any angle in between and
so we know it does move the same way you're moving the Earth right now.
there will be some motion.
The crust of the Earth, every part of the Earth, your energy is part of the convection and that's going on.
We must bear in mind that work is a scalar, and it can be positive or negative. Work will have a positive value when the applied force is in the same direction as the object's motion, like when pushing the box.
So he just said the same thing over and over again. So this is the part, it's a 4-minute video and he's just saying the same thing. So what is this? This doesn't really clarify what energy, force, work, pressure, weight, doesn't really clarify heat, doesn't really clarify anything. And yet he titled it Work and Energy.
And work will have a negative value if the applied force is in the direction opposite the object's motion, like if your baby brother pushes the box the other way, but without enough force to stop it from moving forward.
So this whole idea of positive and negative is just, again, silly. They're always exchanges. So obviously you can be on the gaining energy side or you could be on the losing energy side. But it's just silly to call it positive or negative work.
The sign on work is very important because it tells us if the speed of an object will increase or decrease as a result of applying the work.
So again, it's just another way of saying, are you decelerating, taking something's motion, or are you accelerating, giving it motion? So again, it's just, there is an absolute truth, frankly, in the real world. We can't see it, but it does exist, and Newton proved that also.
Another elusive term is quite simply the capacity to do work, and this is summarized in the work-energy theorem.
So there's nothing summarized here. So again, just absolute bullshit. The KE part means 1/2 mv squared, and that's not what any net thing equals. So Newton clearly said if you want to know the net force or the net work or the net power, you just find the net momentum change. Whatever the net momentum change is, that's what the net anything else is. Because the force is momentum. Work is momentum. Your momentum left behind, so to speak.
This states that when work is done on an object, there will be a change in that object's kinetic energy, which is the energy of motion.
So again, more bullshit. Momentum is the energy of motion. So again, no clarification here at all. Just a silly duality. Here's two energy formulas for no good reason. Even though momentum works perfectly, Galileo could see it, Descartes could see it. Newton could see how it all seems very conservative. And for some dopey reason, they broke what works perfectly. For no good reason. Because a religious lunatic said there's something called a living force.
This also means that an object in motion is able to do work on another.
So he just showed a bowling ball hitting a bowling pin. And it won't transfer kinetic energy. So it's just a lie. It's not going to transfer kinetic energy. It's just going to transfer momentum. That's all it can do, is transfer momentum. It can never transfer the kinetic energy. It's just not possible. The pins will never collect the kinetic energy. They will only collect the momentum from the ball. Whatever momentum the ball loses, that's exactly what the pins have.
Object. The work-energy theorem brings together concepts from Newton's laws and kinematics to describe motion in a way that we will examine further in the next clip.
Whatever the next clip is, so I guess I have to find the next clip. Yeah, whatever that is. We must simply purge for now.
For now, we must simply purge ourselves of any prior connotations of the word energy.
Just believe me, Professor Dave. Let me tell you what energy is and what the connotations are. So I've just stated, he basically just said that work is kinetic energy and it can never be transferred. So the thrust of a rocket engine, measure the kinetic energy, it won't tell you how fast the rocket goes. Won't have anything to do with it. Measure the momentum of the exhaust, it'll tell you exactly how fast your rocket's going to go. Momentum works, kinetic energy fails every test.
And understand that it merely describes a property of an object or system that can be transferred into another object or system.
Right, so then all you're doing, you're transferring, and the only part you can transfer is the MV part. You can't transfer the squared part. The squared part never transfers. Unless you have two objects that are identical and you pretend there's a squared part and then you pretend there's a squared part. But only in pretend physics can you transfer the squared part.
Often in the form of work. There are different kinds of energy.
So there's no difference in the kinds of energy, really. It's always about applying a pressure, a velocity, and you can connect those two things. Pressure equals velocity. So pressure is stored velocity. And that's all you're really saying. So everything can be understood as being either storage or release. But that's all there is. There's just velocity stored as pressure, or velocity actively being a velocity.
Including kinetic and potential energies.
So there's no such thing as potential energy. There's just no, it doesn't exist as a real concept that there's any potential. So just say if I have a boat on the side of the Mississippi River, the boat doesn't contain any potential. The river contains potential to move the boat, okay, but it's not potential energy. It's quite obviously kinetic energy. It's real energy. It's right there in front of you energy. It's already moving energy. It's kinetic in the sense that it's motional energy.
Thermal energy.
Obviously thermal energy is moving. Okay, it's mass moving a velocity. And that's all it is. So heat is always mass moving a velocity.
Chemical energy and more.
So the chemical part is the stored part in the sense that you've compressed an atom, you've compressed some electrons, and they have a capacity to elastically uncompress. So you've stored the heat as pressure. And
we will discuss all of these when the time comes. Once again, the SI unit for energy is the joule, which is defined as a Newton meter, even though energy is not always transferred in the form of work.
So whatever that even means, again, it always has to be transferred in the form of something. So what's the difference? Smirk. So when it's not work, it's smirk. The transfer is smirky. I mean, it's just ridiculous. It's always just transferred. One object transfers its state with another object it has contact with. And depending on how much contact it has, will decide how much exchange it can make.
But our understanding of energy will grow as we examine the various
oh, geez, it's just disgusting. Our
types of energy. So let's move on to that part of the course.
Ugh, disgusting. Ew. Just the whole idea of the pretense of claiming to own the territory and be an authority and be, to argue as in some other way than to say, I'm just going to present an argument. You either understand it logically or you don't. But that's all I can do is present you an argument. And instead of doing it that way, they just pretend that they have some right to claim, listen to me because I'm an authority. I don't have to earn it. I don't have to persuade you. You're just supposed to believe because I'm an authority. Ew. Creepy. Teachers are creepy. Alright, so nobody commented still? That's a little weird. Somebody type a comment, please. Because it appears I'm not seeing anything. So, I have to verify that the chat is working. So, come on, you can do it. Well, if the chat's broken, Gary, you can't tell. Okay, so, there we go. Let's see. Have you heard of any 60 symbols? Well, of course, I've watched everything on the internet, for fuck's sake, that has something to do with physics. I've even watched Hindi videos, even though I don't understand what the fuck they're saying. So, yes, I think I've seen all the 60 symbols videos. And again, they're so far short of getting to the subject, and it's always, so many of them are almost so juvenile that you're saying, oh, this is a video for 10-year-olds. It's not really a video for a science person. I remember some woman explaining gravity, and it was pathetically bad. I don't know what to say to you. That, they're always, again, it's always the antics, too. We have to use a helium balloon and explode it or some other stupid thing. And they don't really get to any of the important details. Hydrogen 2. Yeah. Hydrogen 2. Oh, isn't that an interesting concept? Why don't you draw me some hydrogen 2? What does hydrogen 2 look like? Alright. We are here. I don't know what that even means, but okay. Oh, you're a little late. No, sorry. Yeah, I was asking a half hour ago. So, the other guy already solved the problem. But okay, people. You can do your hello and hey and whatevers. Okay, thank you. Better late than never, or, well, sometimes it's just, better never than late. Yeah. Anyway, alright, so that's the end of the video. Yes, now that sucks. Let's see what he says.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content.
Yeah, I didn't do all that stuff because I'm just so great and so special, and I just did such a great video explaining absolute trivial nothing. I said just about nothing. I said energy's a scalar. Even though it's always a vector. So even though it's always a vector, I mean, you could always understand it as vectors. You can understand the heats as vectors. You can understand the motion as vectors. You can understand it as vectors. It's always a vector. Oh, no, it's scaling. Whatever scaling is. I don't know what scaling is exactly. How the fuck you scale? So when you're riding your bicycle down the street or driving your car, you're magically scaling. Yeah, you have all this scalar energy. Besides your momentum, you have a whole bunch of scalaring energy. It's just so ridiculous. Silly, stupid, moronic, awful, horrible. Alright, let's see. Maybe I can find another video quickly. I don't know if I want to do another one, though. Ugh. I will have to decide what to do. Yeah, I'll decide what to do. I'm not even sure if this is one video, unfortunately. I guess if it's 2 videos, it doesn't make any difference, but whatever. At least I'll know that I can just turn off the browser and the video will still be possible to be a complete video, so that'll be interesting. I've never heard a sensible explanation for a scalar. I would guess they would consider heat a scalar. Yeah, I argue that no, they can't consider it a scalar because it's always in the form of, it's derived from something's momentum. Yeah, see, it's just so hard because what's the velocity of heat, right? I mean, you're talking about tiny, tiny things moving really, really fast, but their actual, like, the heat moves through the substance very slowly. So again, we're back to some sort of like electricity argument. Somehow you have something called the drift velocity. When you know nothing's moving the drift velocity, that doesn't have anything to do with anything. That's just I haven't considered how they would view heat. But I mean, all heat is dispersive, right? I mean, that's the key to heat, is that it is very hard to make heat go in one direction. So, heat is just dispersive, and that's why it's not very useful, is because it's not going in one direction. So if you can't make the heat go in one direction, you can't really use it to do any useful work, any useful exchanges. I mean, that's all you're really doing with like geothermal or something. You're just converting the heat that's going in all directions, and you're making it go in one direction from hot to cold. In one direction through your pipe. But yeah, I don't know who invented that scalar vector nonsense. Obviously, it happened after like 1850. And you're just saying, what the hell is that crap? I mean, it's just such a desperate thing. Basically, I guess they got challenged because the only vectors you can see happening in the exchanges are vectors of momentum. And so I guess they had to come up with some way that the kinetic energy is hidden, and therefore they can explain why it doesn't show up in the collision, why it doesn't do anything. But there's no evidence of its existence. And again, I've said it so many times, I mean, this whole argument should be over. I take the object going 5, the 5 mass going 10V, and I add 5 mass gracefully. I end up with a 10 mass going 5V. So I have the same momentum, I just have a heavy object, big M, small v. I started with a big V and a small m, have the same exact momentum, and yet they say there's a bunch of scalar energy that created heat and motion. And you're arguing, well, how can you create heat and motion without using the momentum? That's like saying I can knock down the bowling pins and my ball still has the same velocity. I can't do that. The ball can't keep its momentum and give it away. It can't do that. So it's just so illogical. And it's just amazing how many people are willing to defend something so illogical. Like that Scott asshole. He probably defends that notion. Some kind of notion that I can create heat and I don't have to use momentum to do it. Well, obviously explosions are just so easily dissected as motions and directions, right? So, I mean, some detective who does the processing of a bomb scene, I mean, it's just becomes some kind of obvious that there's reflection vectors. I mean, all the vectors are so obvious. You can just, they can place reconstruct the bomb, and they can just show that, well, here's where the heaviest piece is. This is where the lightest piece is. I mean, it's all vectors. I mean, the heat is just another way of saying particle. There's no point in making a distinction between the tiny little particles being moved by the explosion, the little grains of sand, and the big lumpy rocks. I mean, it's kind of silly to say that's different. It's the same thing. Heat is just small things moving. It's not any different than that. A lot of modern physics theories seem so insane and lack zero rational explanation as to why we should believe. Well, why we should believe, that's the key thing. They keep claiming they're showing you evidence, and there's no evidence. Right? They claim there's antimatter. Have you seen a piece of antimatter? Have they shown you any evidence of something called an antimatter? They'll call something a positron emitting beam. It doesn't emit any positrons. The positrons are created after it hits a radioactive isotope inside the person. They're just imaginary positrons. And yet they call the thing a positron emitter when it's not emitting any positrons. I mean, they're so dishonest. I mean, they get people to believe this shit. Quantum computer, qubit. There's no fucking such thing. There's no qubits. And even if there were, it's as implausible as a magic, a real wizard. Because the qubit would have to do something impossible, which is know the answer before it read the question. Yeah, it really is pathetic that they can get away with such exaggerated descriptions of the quality of their experimental evidence. Their experimental evidence is garbage. I have used Stern Gerlach over and over, but it's just a funny example because they're literally heating, okay, a volume of a material. So it can be, they use silver in the original experiment, now they use cesium. And all they're doing is heating it and forcing the atoms to eject. So they're shooting cesium atoms through space and having them hit a target. And then they're claiming, and moving it through a magnetic field. And then they're claiming the cesium atom is moving based on the spin of its electrons. And you're just like, how could you draw that conclusion? It's a fucking whole atom. All atoms have some polarity. And so, yeah, it's going to turn or move in a magnetic field. Individual atoms are magnetic. Substances that aren't magnetic, they are magnetic as individual atoms. And you could understand it even as a charge argument, that they have a charged polarity, and they will turn in a magnetic field. It's not a surprise. But to say they know they're measuring electron spin is it's just crazy. When you know the nucleus of the atom is deciding where the atom's going to go. That's where all the mass is. So, come on, people. So we need some more, what subject would you like a little clarification on? Come on, some kind of useful feedback would be appreciated. You can do it. How big a weasel is Professor Dave? I mean, they're just such hypocrites. They'll critique the weak theories, and they won't accept any critique of their weak theory. Let's see, what's your thought on the blurry photo of a black hole NASA captured? Right, well, whatever that is, I don't, is there some recent picture of a black hole they have? I don't know. Obviously, I think there's dense matter, okay, like neutron stars. But the idea of a singularity, that is, the idea that matter can pile up on itself, okay, that all the electrons can be in one place and all the protons can be in one place, is ridiculous, okay. And I think the universe can only create so much pressure. There's only so much heat in the universe, so it obviously can't create an infinite amount of pressure. So I really just don't think black hole is a realistic manifestation of physics. Yeah, well, that donut thing, I don't even know if that's really technically NASA. But anyway, I mean, it was obviously radio telescope horseshit. Okay. And there's every evidence that it was just shaped by the will of the shapers. So they were trying to make a black hole and they made one. It was, streams, images fly by me and somebody says possum. And so all these images, anything that's anything close to a possum, I say yes to. Then eventually, after a million images, if I put all those images together, it's probably going to look like a possum. Even though the individual images didn't look like a possum. And one of them, only the nose was a possum, and the other one, only the tail was a possum. So even though all the individual images were not a possum, when I put a million of them together, the cumulative effect is going to be possum. All right, let's see. Well, I'm student of chemistry. I love that. I love, yes, I mean, science is great. It's fantastic. Learn as much of it as you can. But don't believe them, okay? Just don't believe them out of faith. If it doesn't make sense, recognize, okay, they're saying something is useful. Okay, fine. Is it the truth? And I've discovered your channel. It seems interesting. Well, I'm telling you that it's so simple. The real physics is really simple. And if you want to understand chemistry, you really have to understand atoms as magnetic. The electrons and protons are the magnetic monopoles, and they don't orbit, and they don't spin, and they don't do all that crap. When you share an electron, you literally share it. It stays in that position, and the two atoms share its position. That would be the big, don't be fooled by their silly nonsense. And you sort of know it because when you make your stick models of atoms in chemistry, there's no spinning. Nothing's spinning around. You literally can connect electron, and then you can have two nucleuses connected to that one electron. I mean, you literally can do it. And that's really the correct configuration. Let's see, can multiple electrons be stacked densely in between the protons? Yeah, well, that's what a neutron star is. A neutron star is basically a bunch of electrons and protons stacked magnetically. And if so, how would the circumstance like that happen? Well, it's just because you're purifying through compression. So there's lots of examples, I suppose, where you can use compression. Well, let's say heat is used in the Earth's crust, and elements separate out because of temperature and density. So all the gold has the same mass, so it sinks into the liquid, the magma, and it all ends up in the same place because it has the same buoyancy. And all the silver has its own buoyancy, so it separates stuff out. So you can understand under the intense pressure, all of the electrons and protons will have all of their positions made minimally efficient. I mean, they'll have the highest efficiency because it's the highest pressure. And so their density would get higher and higher, and the efficiency with which they're vibrating in the force is lower and lower because one of them can't vibrate without vibrating all of them. So everything is dampened. So any motion is dampened by the lead shield, so to speak. There's no sound that could travel anywhere because it all gets dampened out by the structure. So it becomes very highly efficient and highly compact. And apparently from observation, they can tell that it's highly magnetic. You know. You can't have multiple electrons, right? It always has to be electron, proton, electron, proton, electron, proton, electron, you know. Electrons can't be next to each other and protons can't be next to each other. They can be close to each other. Proton, proton, electron, electron. So that their attractive force is stronger than the repulsive force because of the distances. So, but that's all you can do. You can't undo, like I said, that's why it takes pressure to create that, is because you still have electrons closer to each other than they want to be. But you're compensating it for by having the proton and the electron so close to each other that that attractive force is stronger than the, obviously it's not really attraction, it's just absence of push, but I'm just saying, so that absence of push is stronger than the pushing force repelling the electrons because of the distance difference. It's a force balance. You're just balancing the repulsive force against the attractive force. I hate using those words, but you know, we're sort of stuck with the language that exists. Alright, that's where people bring up singularity. Like I said, yeah, well, they can bring it up all they want, but I mean, that is a bold statement that should be proven with some kind of evidence. I'm going to put two physical things in the same space. I mean, I just don't think you can do that. I don't think there's any physics that allows a proton and an electron to be occupying the same space. And certainly for two electrons to occupy the same space, not possible. Well, certainly they can't cause force, so I'm just saying it's, you know, electrons are only reflecting the universe, protons are only reflecting the universe. They don't do anything. They're not jellyfish. They're not making something. They can only be at equilibrium with the force that's hitting them. So the force is always external to electrons and protons. And all they can do is use or occupy some force being moved, but that's all they can do. Magnets don't produce any force. They just take the force that's coming in and they reflect it with a pattern that other magnets can see. That's it. So they're just basically filtering the force. The force comes in chaotic, they filter it into a polarized force, and now other magnets can see it and be affected by it. Because it's been segregated into proton and electron force. It comes in as mixed, and it comes out segregated in a pattern. I mean, a simple way to understand it is the force has all the motion, and the matter, the electrons and protons, have all the mass. And then you start making MV. Yeah, well, Heisenberg was an asshole, and obviously the uncertainty principle is just made out of nothing. Heisenberg indeterminacy principle, uncertainty principle is what it's usually called. Um, but yeah, it's clearly just made up, right? We can't see any of these particles. They're just pretending they're not in a place and they don't know how to go anywhere. It's just absolute babble, in my opinion. It's just made up. It might as well be as bad as the multiverse. It's just a silly statement made about a circumstance we can't test. So I say, show me. And they're never going to show me. Let's see. I find it not logic. Can you clarify it me? I studied it in my, whatever that is, atomistic class. Let's see. Sorry, my English is not correct. It's not my first language. Yeah, sorry. I mean, I'm not that demanding. I mean, I appreciate people who have more than one language. I can barely speak English, so very good of you. I barely have mastered one language. But anyway, so it's okay to try, but if you don't try well enough, I can't do much about it. But anyway, yes, Heisenberg is just a story, okay? It might as well be Red Riding Hood or Goldilocks. It's just a story. It doesn't, you have absolutely no obligation to believe electrons aren't in specific locations with specific momentum vectors. You have no obligation to believe anything else is the truth. No obligation whatsoever. There's nothing in the real evidence that indicates photons don't travel dead straight lines. So, I mean, the whole thing is just made up shit. All right. The force exists because of the fact matter takes up space, which creates pressure. Obviously, you can't say the force exists because of that. The force is BBs with a constant velocity that they can never lose, and all you have is clumpy things in the field of BBs. All right, and the clumpy things, by specific rules, BBs can stick to them and push them, or reflect, or be converted. But that's it. I mean, that simple model works. So when you say the force exists because of, I'm saying now, what exists is the force, and what you can do is change its pattern. Just again, like I said, all I have to do is move electrons fast enough, and I change the color that's being emitted from this hand. So if I could actually move the hand fast enough, it would change color. It would go bluer and bluer and bluer and bluer. Does that mean my hand emitted blue? Or does it mean I just took what was already in the field and I just changed what it looks like? I took a long frequency and converted it into a short frequency, or a wavelength. But the argument that the force takes up space obviously increases the pressure in the universe. You can understand, right? So the more matter bits in the field of force, the hotter the force gets, right? Because I've changed the volume the force is free to move in. So any clumps of matter I put in the universe, those clumps have to make the force hotter. But by the same token, those pieces of matter will absorb energy out of the force. They'll equalize their pressure. And so the equilibrium point will be the same temperature as it would have been if the matter didn't exist, because now the matter's absorbing some of the temperature. I mean, it's just sort of interesting to consider something like the sun, right? I mean, the Earth is doing it too. I mean, it has a layer on the surface that's at equilibrium with the universe. But nothing else is at equilibrium with the universe. Just the surface. So the sun's surface is this layer Where you go in, the pressure increases. You go out, the pressure decreases. It's this layer of equilibrium. I mean, technically, an environment is, like even the atmosphere and the surface of the Earth is the same kind of equilibrium. The molecules are hitting the Earth and they impose some extra momentum, and at the same time, the Earth is pushing on the atmosphere, imposing more momentum. So it's just exchanging in an equilibrium sense. It can never get out of equilibrium. Would be great if the science could just redo the Eddington experiment. Well, no, don't redo it. Only do it from space. So, it's only a subtly different experiment from space. I mean, it's the same experiment, except you don't need an eclipse, which is hugely advantageous. And you don't have any atmospheric bullshit to worry about. So you have 400 times better viewing from space. So you do the experiment from space. And the fact that they haven't officially done it, right? There's no official statement saying from NASA that, yes, we pointed a camera and we took some pictures outside the corona of the sun and, we observed blah, blah, blah. Now, a NASA engineer who worked with lasers for 10 years at NASA says they have no data showing light bending outside the corona of the sun. So there's no evidence of any light bending. So they have zero evidence of it happening. And no, do they report that? Do they tell the people that? No. Do they say overtly, we tried the experiment and we didn't see any bending? They don't say it. Do you really think they've never tried it? I mean, it's a $5 experiment from space. I mean, literally. You're just talking about 5 minutes of satellite time. 5 minutes. Am I supposed to really believe they've never even tried it? You could do it with a moderate telescope from inside the space station because of the 400 times better seeing. And we're supposed to believe they never tried it? It's ridiculous. Crazy how we have all this technology and none of the scientists want to do their job. Depressing. Yes, exactly. I mean, they haven't dropped 1 pound 4 feet and 4 pounds 1 foot and proven, that it's the same energy. That dropping 2 seconds in gravity means you got 4 units of energy. They've never even shored that theory up. Okay, I will be heading out. Someone with real credentials give you a fair look at your arguments. Okay. So whatever that means, it'd be nice, but yeah. Unfortunately, that's what this whole point is that these talking head, hypocritical, duplicitous, for-profit science whores, science pimps, they're not going to do that. And morons will just keep paying them not to do that. It seems like with the telescopes we have now, we should just try the experiment with the technology. Well, like I said, ground-based telescopes are feeble. They're blind by comparison. I mean, it's just, I wouldn't, if somebody wanted to fund a ground-based telescope, I'd say, fuck you. I mean, it's dead technology. I mean, just the gravity alone on Earth, the surface, it warps the fucking mirrors. You can't make the damn things very big. Then you have to use this, the stupid, whatever they called that stupid thing they put up with all the different little segmented mirrors. You have to use something that's a composite image made out of different images, and that's all depends on a whole bunch of technology. So, but what's the point of looking through the atmosphere? It's just fail all over the place. Fuck it. It doesn't work. I mean, it worked, 300 years ago. It was a great advance, but not anymore. Okay, ground-based viewing of the universe is just idiotic. No point in doing it. I mean, just the fact that you can only see at night, and the fact that there's a whole bunch of light now coming out of big cities that bounces off the atmosphere and ruins your seeing anyway. So you can't even see at night anymore. So what's the point? Yeah, they make the excuse that Hubble can't look at the sun. But the truth, of course, it could. All I have to do is put a satellite right in front of the Hubble telescope, and it will block all the radiation from the sun. So it's completely doable to block all the radiation from the sun, the photons. So it's just a lie that they can't do it. Again, you can't do the viewing through the sun's corona. So you have to go a whole radius of the sun, away from the sun, to actually do the experiment. Because there's a ton of plasma, shooting out of the sun. So you viewing through the plasma, obviously you can get some distortion of an image, because it's like viewing through fog. It's obviously can create false images. So that's silly. That's just scatter. You have to do it far enough from the sun where there's nothing of the sun's atmosphere, so to speak, in the way. That's why they should use Jupiter. Jupiter has an almost nothing, outside the chemical atmosphere of Jupiter, there's not a whole bunch of particles flying out of Jupiter. The sun has a ton of particles flying out of it. Okay, Jupiter doesn't. And frankly, you can do the experiment much closer to Jupiter and its surface. And so in a sense, the gravitational pull will be even higher because you don't have to go as far away from the object. I mean, the surface of the sun is only 80 times the gravity of Earth. I mean, you think it's supposed to be like 8 million times, but it's only 80 times. And you can understand that, a radius away, it's only 40 times. So it's not very high gravity. Where the surface of Jupiter is like maybe 100 times the gravity of Earth. So, it might actually be mathematically a better choice. I mean, Einstein even talked about using Jupiter. He wasn't very confident that it would work, but he did talk about it as a possibility. I mean, Einstein wasn't completely illogical, I mean, Einstein was very smart. It's just that bent space is just so wooey and silly, and it's such a hypocrisy of his to talk about spooky action when his entire mechanism is spooky action. His theory is just as spooky as their theories. But he was smart in a sense that, it took me a while to dissect this one on my own, that, for an Einstein ring to happen, because gravity isn't a magnifying mirror, it's exactly the opposite of a magnifying mirror. It does more bending in the middle than it does on the outside. So, because of that, there would only be one tiny shred of space around an object where the bending would be the right amount to send it to, say, an Earth. And Einstein pointed out how, in that tiny amount of space, the volume of photons would be so low that you could never make an image out of it. Okay, let's see. It seems there is a possibility that some of the people you've contacted before have informed others of your channel's existence. I don't know what that's based on. Is there any possibility? Well, it appears not, so I'm just saying I have to go out and be aggressive, and I'm not an aggressive person, so frankly I'm not very aggressive. I don't make comments on their channel and try to drag them into the conversation. I just make one comment and then they usually block me for it, which is really bullshit. But I rarely comment, and I send emails just requesting, hey, look, we disagree, okay, I can't fix that. And yeah, I might seem a little bit hostile, but all I'm talking here is for the truth. And so for the sake of the truth, will you engage in this conversation? And I can't get them to do it, all right, because they take it automatically as hostility. And so you just can't do much about it. So, I mean, I didn't start calling Professor Dave an asshole until he proved he was one. I mean, I gave him the opportunity to, name your price. Tell me how much it takes to get you to care about these subjects. And he wouldn't even politely do that. He just dismissed the whole subject as if it's not possible for you to have a discussion with me because I'm an expert and you're an asshole. And that was his attitude. So why should I react to that with anything other than hostility? Why should I say something other than fuck you? Okay, I'm not going to be treated like garbage by this douchebag. He doesn't own me, and he doesn't own the subject. And this whole idea that these authorities have all the answers is just a lie. They don't. They don't have any of them. Seriously, wow, I don't know what that means, but fine. The wow part is again, like I said, look, I've been doing this for a long time, over 10 years. And my initial arguments, I just knew it was wrong. Okay, I knew it was wrong, but I didn't know all the details you need to know to be able to argue it was wrong. Like I first proposed Lesage gravity without knowing it had already been proposed, particle gravity. And then I didn't know that there was this decisive drag argument. And so I was like, oh, fuck, yeah, that's pretty bad. How the hell am I going to get out of this now? And, so it was, I called the channel draft because I'm drafting. But the fact is now I own it. I got it. I mean, it all works. Every bit of the shit I've been saying for 10 years has been absolutely right. And this system of this mechanical model of the universe works by these simple, silly rules. I mean, just so simple. 2 kinds of force, 2 kinds of matter, 3 kinds of interactions. And it works. It explains everything. It was about Einstein. I don't know what that even means, though. It was about Einstein. What part is the wow part about Einstein? I'm just saying, what wows you? The theory of bent space that says, I mean, it's a non-contribution, right? I mean, Newton could have said the invisible man does it. And isn't that the same thing Einstein's saying? Is an invisible, non-real force that's not a force, this thing gives things momentum. And again, it's just a free energy theory then. Because you're making things move and you're not using anything. You're not exchanging momentum. So how do you make something move without exchanging momentum? That's free energy. And then they say, the whole universe is getting colder. Well, how the fuck could it possibly get colder when every material object is getting hotter because of this free energy? I mean, it's just such a bad theory. It doesn't add any value. Talking about space-time, and then the time part only matters when you're going close to the speed of light. So how the fuck could that mean anything? Nothing's going to go that fast, so why are we even bothering with the whole conversation is meaningless. Yeah, well, I'm just saying the light bending thing is really a bold statement that should require bold evidence because forces don't interact with forces. You can't move light with magnetism. You can't move light with electricity, right? You can only move light by having it hit material objects. And you can't bang a laser beam into a laser beam. I mean, all these arguments you can make how forces can't possibly bend another force. So gravity can't bend light. Now, they have all these wacky images from the Hubble telescope, and obviously the argument is these are synthesized images. They're not technically photographs, right? They're data collections that go through processing. And that's a dangerous thing because, you know, the algorithm you're using to process the data can create bullshit. But it's also true that if a supernova blows up and leaves a ring of matter, we could see it. You know, and it wouldn't be some big surprise that there's a ring. Well, you know, it's bullshit because you know that it's such a simple experiment from space, and we've been in space for 50 years, and they've never done the experiment. I mean, it's just, you could do it with a GoPro camera. The seeing is so good, right? 400 times better seeing. It's 400 times better. It means you only need a telescope, you know, that's 2 of that 400. You know what I'm saying? I mean, you can have a telescope that's 400 times smaller. You know, so I'm just saying that obviously it's a really easy experiment from space. Let's see. When do you think Professor Dave will make a video on Gary? Well, let's say if Gary keeps making Professor Dave videos, and let's say Gary could get 500 views on those videos, then Dave might feel the pressure. But I'd still think it all depends on whether he has any integrity at all. Like if he cares about the truth at all. Because he could turn this to his advantage and say, yes, there are some good arguments here and science should fix these misimpressions. Wave particle is silly. Okay, a lot of these statements, having an energy duality doesn't make much sense. Was Leibniz really a credible physicist? I mean, he didn't do any experiments and he just claimed this thing exists. So should we really believe something just because some religious kook claimed it 350 years ago, or should we really have hard evidence of it? And obviously every experiment provides evidence against it. So does he have the integrity to admit it's a conversation that needs to take place? Physics hasn't dropped 1 pound 4 feet and 4 pounds 1 foot. It hasn't done the simplest experiments. It hasn't turned a scale sideways and then moved an elephant into it at a velocity and then taken a mouse at the same velocity and see if they can read mouse for the mouse and elephant for the elephant in terms of the weight, because that motion is exactly the momentum. So if you can make an elephant weigh elephant and I can make a mouse weigh mouse with the same velocity, that means that's exactly the momentum that gravity is creating. And we could just have the number. We could say 1 mile an hour. Now I've calculated to be about 1 mile an hour. So that's my approximated calculation. You're basically traveling into the earth at 1 mile an hour when you're just sitting in your chair. You're creating exactly the same impulse energy, but your impulse energy is constant. So you're a constant impulse energy. Where if I swing the elephant, it's not, you know, it's just an impulse and that's it. It's over. He pushes the scale moves back. You're getting pushed by a constant 1 mile an hour force. When do you think? Okay, now I've talked with Dave like once in a comment section, and he has just such a smug. He's such a smug piece of shit. Yes, that's all you can say, right? Like I said, that was my interaction. I said, "Come on, how much do I have to pay you? 2,000, 4,000, what's a reasonable number to give me this 5 minutes? And you can choose to answer my claims or you can choose to ignore them. Just play the 5-minute video on your channel and show me you have some integrity. And he won't do it. So it's like a flat earther willing to pay him to debunk the flat earther, and he doesn't take the flat earther's money. Do you think that would actually happen if some flat earther says, I'll pay you $2,000 to play one of my 5-minute videos, and you can respond or not respond? Do you think Professor Dave wouldn't take the money and wouldn't have fun debunking the theory? The fact is, he ain't going to debunk me that easy. He's not going to be able to debunk me at all, because nothing I've described in these videos is untrue. This description of rolling a ball on a flat surface is absolutely true. It's what actually happens. And he can't deal with that because it proves there's no kinetic energy. The simple experiment proves it. There's only twice the heat in the ground. There's not 4 times the heat. The twice as fast object does not have 4 times the energy. It can only make twice the heat. Therefore, it only has twice the energy. Let's see. I don't think he should. I don't know, whatever that is. You could go to the root of maybe playing with clickbait videos to get Dave's attention. Well, I am in a sense, right? I mean, I'm putting this image up with, you're just a weak coward. This isn't stuff I want to do. I mean, I don't have any interest in goofing, putting a dunce hat on him or doing some kind of buffooning crap. It's not I don't want to play that. I want to have a conversation, but these pussies won't let it happen. I mean, I should just take his image and, put an empty nutsack under it, because he's a ballless little weasel. But I don't think that's how you have a fair fight. Fair fighting isn't photoshopping each other. Okay, but anyway, whatever. I don't think he should. All right, draft physics will be non-existence if Dave made a video. So again, you're saying so. And so can you make a counter argument? Can you explain, how 2 units of force, that is 2 units of time and gravity, equals 4 units of energy? Could you explain how that works? It's 9.8 meters per 1 second. If I'm in it for 2 seconds, how do I gain 4 units of energy? Could you just explain that, retard? Not because his arguments, but because Dave will raid in Mendham's channel with so many, whatever this is, gnomites, it will be overwhelming. What's overwhelming? What do you think I'm afraid of trolls? I mean, come on, too silly. I guess you could say bad publicity is good. Yes, so why did you say what you just said? Any publicity is good, so who cares? But I tend to disagree. I don't know why you bother. I'm just saying I haven't done anything wrong. Okay, so they can't pick on anything real. So what do I have to fear? I don't have anything to fear. I can argue my argument. I can defend what I'm saying. So why do I have anything to fear? Okay, read the rest of my comment. I'm not going to bother reading it because I read it. It's garbage. I don't know what you're talking about. I read the damn thing. Let's see. Draft physics will be non-existent if Dave made a video. So that's what you said. I don't even know what that even means. Not because of his arguments. I don't know. It's just like, again, I don't even know what this mush means. The only hope we have is that there's some portion of Dave's argument that really loves science, and they want it to have integrity, and they want the truth. They don't want lies and bullshit. And that's all. The only hope we have is that there's some percentage of the human race that actually does love science and love the truth. Because the truth is, there are good counter arguments and they need to be addressed. These arguments need to be addressed. Why can rockets not collect any kinetic energy ever? I can never convert kinetic energy into the motion of the spacecraft. How can you believe in a form of energy that I can't transfer? If I can't transfer it, how can it be called energy if I can't transfer it to another object? I mean, it's a ridiculous definition. Well, Gilbert, I guess we have some sort of time warp problem, but whatever. Your comment wasn't very productive, in my opinion. I'm annihilated by being ignored, so that annihilates me. Any attention I can get, I win. Okay, so I'm just saying that's the only way to look at this. I need the exposure because that's the only way I can reach the rational humans on Earth, if there are any. The fair cops, the white hatters, the people who just care about facts and the truth. I need to talk to them. Talking to physics fanatics, okay, religious fanatics, yeah, that's a dead end. I'm not going to convince the crystal rubbers. Even if I convinced them, it wouldn't matter because their business is selling crystals. So they don't care about the truth. If it doesn't work, well, they don't care whether it works or not. They just care whether they can convince some sucker that it does. That's what's wrong with this show physics on the internet, is that the money has corrupted it. They're not in it for the science. They're not Rutherfords, okay? They're not even the guy who really invented the first radio, right? There's a guy who invented the crystal, and that you have the sketchy contact with the crystal, and that creates the little sparks that create the radio wave. So the crystal radio was really invented by this guy. He really invented the core of Marconi's radio. So Marconi had no radio without this guy's invention, and he explicitly didn't patent it. He overtly gave it to the world as the technology. He could have been the patent holder, and he said, no, I'm a scientist. I don't give a fuck about owning the goddamn science. And I don't even know the guy's name. I mean, isn't that disgusting? I mean, the guy really is Nobel Prize worthy. He really is, a great scientist. And instead I know Marconi's name and Tesla, who were both just saying, show me the fucking money. Show me the fucking money. Show me the fucking money. That's why the world sucks. They make heroes out of the criminals. Let's see. Being of those ambiguities, you see this. The reason I question, oh dear, this is going to be tough, every fundamental of physics, and physics including mass, energy, time, space, whatever. I don't know what you're saying. I don't know if I care. That's what I'm doing in my research. We have a problem. I don't even know what any of that means, but yes, then I don't know. I'm saying there certainly is force. There certainly is motion, there certainly is matter, there's three-dimensional space. So if you want to say there's some other woolly shit, I'm going to find you just as obnoxious as regular physics. So that's not going to... There's no point. I don't really need to defeat you. I need to defeat them. They're the ones that have all the cards. Okay, playing with you would be a waste of time. You don't got anything to give me. All right, anyway. This is completely unrelated, but I did see the Wikipedia draft on ephilism. It's one of those, whatever it is, nuts. Yeah, and it's all just guilt by association, right? But so because a couple of ephilists had other philosophies where they thought it was somehow brilliant to go shoot children, it's the ephilist's fault. So if he believed in ice cream, he believed chocolate was the best flavor ice cream. So does that mean anybody who believes chocolate ice cream is the best flavor is guilty of killing kids? I mean, it's an idiotic extrapolation to say that there's something in my philosophy or anything I've argued that has anything to do with social terrorism, because it doesn't. I've never suggested any social terrorism. I mean, it's just idiotic. I've done exactly the opposite. I'm the one who keeps saying protesters suck. Kill them. Run them over. Burn them. I don't care. They're trying to get attention without winning the argument. I mean, they're cheaters. Fuck protesters. So, it's not the right subject anyway, so please, let's not mix the subjects. But it's clearly just stupid, to say that, I don't know, that some guy beating his wife and he also happens to be a racist. Does it mean that all the racists also beat their wives? I mean, it's just too silly. Sometimes I encounter contradictions with formula and definition. For example, the masse. I don't know what that is. Masse? I don't know what that is. BC equals because. Well, I don't care. I speak English. I really don't do BCing. I agree. It's dumb. LOL. Okay, I don't know what any of this is, so... Jesus. You people really aren't great at sticking to the subject, but whatever. I get what I get, and that's unfortunate. I just keep getting what I get instead of getting something good. But whatever. I appreciate your effort. It's just that it's kind of yellow bus effort. It's just not quite good enough. Little yellow bus. See, sooner or later, somebody's got to show up that says, oh yeah, I'm an honest, PhD graduate from college. I see what you're saying. There are a lot of under incomplete theories in physics, and some of them are grotesquely incomplete in the fact that they could really do these experiments. I mean, it's not complicated to do these lever experiments, weighing things horizontally. It's not very challenging. Physics really should be able to do this shit. It is just, you hate to use the concept of intuition for any of this stuff and say, oh, I had an intuition. Because I guess it just really is that common sense thing. If somebody tells me, like I said as a kid, they tell me that this photon thing, which they describe as almost this most elemental, simplest thing in the universe, travels billions of light years through space in very precise ways, and then they tell me it's doing this. I have to say, well, how the fuck can it do that? It doesn't have snake muscles. So what? There's an external field in billions of light years of space that's pushing it this way and then pushing it that way and then pushing it up and then pushing it down. What the hell are you talking about, right? So, I can't say it was intuition, right? You're just saying that can't be the truth. It's just too, fuck you. That's too fucking complicated. You have to come up with something simpler than that. I mean, the elemental universe can't have jellyfish in it. Fuck you, that's silly. Alright, let's see. Gilbert Jones, aren't you 15? LOL. I remember seeing you say that on a comment. Well, who cares how old he is? But anyway, if your interpretation of the double slit experiment is correct, how do quantum computers work? They don't. There's no evidence. I mean, even that one girl, right? She was working in quantum computing, and she has that physics channel, like Happy Physics or whatever the fuck it's called. And she just pointed out how she got out because it's all horseshit. And it's all horseshit. I mean, there's never going to be a quantum computer. There's never going to be one. And if they make one, all it will do is make noise. Okay? It'll make noise better than anything makes noise in the universe. It'll make randomized chaos better than anything else makes randomized chaos. But it'll never do anything logical. Ever. See, it's just funny that people actually think this fucking thing works. That they actually have a quantum computer somewhere that's actually computed something. Except noise. See, their standard, how they're testing their computer? They're just saying, how fast can it make a random number? Do you get the point? I mean, making a random number means to a logical thing, it's like saying, oh, I have to make errors all over the place. That's the only way I can make random, right? Is I have to fuck up somewhere. Because I have to create something called disorder, whatever the fuck that is. How the fuck do I create disorder? And something that's orderly and logical can't make disorder. So even a regular computer, this happens in the simulations, When you start simulating millions of little dots, what happens is your computer, you're asking it to produce a random number, and it can't really do it anymore. It can't do it fast enough. And so it's losing randomness, and there ends up being patterns in your chaos field because the computer can't do it. It can't do something illogical. And so such an irony. The big failure of regular computers is it has to use a whole bunch of time to make a random number. It can't do it quickly. And the quantum computer can. But who the fuck cares? Because you can't use that to do anything computery. Okay? You can't use that to add 2 plus 2. So that's the funny part. All right. What's mass in physics, honestly? All right. So I don't know why you're worrying about it. It's a concept of a volume, of a property. It's obviously a property, and it's not nothing. So as soon as it's a something, you could argue it requires it's anti-nothing. Okay, so it's something, and the something is a substance, and so you can have a volume of the substance of it, and it is what's moved by stuff that moves. So I mean, I don't even know why you would worry about that as a concept. Just because you see it in the universe. I mean, you see the stars are different than the empty space around them. So what's the conflict? What's the confusion? Anyway, I don't even know, because there are so many contradictions with definitions and same formulas. For example, well, I already pointed that out. I mean, these E bullshit is just nonsense. So don't worry about the energy equations, because they're all nonsense. So why are you worrying about that? They don't have anything to do with it. I mean, Einstein's E equals mc squared is just made up. I mean, it's just a preposterous, just a way of pointing out that the quantum of energy is tiny. Okay, that the energy is in little tiny, 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 tiny chunks. But that's it. It does not say anything else. There's no intrinsic energy in mass. Masses don't have the energy. The boulders don't have any energy. The Sisyphus pushing the boulders have the energy. I really think that analogy is quite suitable. I mean, you have red Sisyphuses and blue Sisyphuses. They move the speed of light when they're not pushing a boulder. There's two kinds of boulders, red boulders and blue boulders. So the red Sisyphuses push red boulders, the blue Sisyphuses push blue boulders. And if a red Sisyphus tries to push a blue boulder, he ends up turning into a blue Sisyphus. Okay. Those three rules, those two concepts, it's solved. And so the mass is the electron and protons have a mass, and the Sisyphuses have to share their momentum with the mass. And so a new MV is created. The Sisyphus has a tiny m and a high big V, and when it connects to an electron, now it turns into a much bigger m and a smaller v. Duh. All done. I just don't think that's too much to expect as an axiom to start with, and you just don't bother saying where did the electrons come from, where did the force bits go? You don't bother with any of that. You just say, okay, that's simple enough as a drawing of the mechanical universe. I don't need anything else. That's all I need to know to build a model and to run it and see it make atoms and see it make molecules and see it make people. And such. So it is disappointing, I used to do this a couple of years ago, 3 years ago, and I might even hit 20 concurrent viewers, and and now I'm stuck at 12, 11. It's kind of depressing. But that's because of YouTube. See, the old days, they would put my video in recommended lists, and I definitely got more new viewers. And now it's just, I just don't think they let me be viewed by anybody new. It's hard to find this channel on YouTube. And on the internet, it's impossible. Because, Google just makes everything disappear. Yeah. YouTube is normalized. I don't know what that exactly. I don't know whether that's a statement. I should know what the hell that even means. I mean, normalization in physics means you take all the infinities and pretend they don't exist. Yeah, so, clearly, YouTube is lowest common denominarized, and it's monetized, and it's lots of things that are not good for intelligent conversation. But yes, it's just a popularity engine, Those who have it will keep it, and it's hard to get it. whatever that threshold you have to get past, to have a growing channel. And it's just hard to get past that threshold. I mean, there's lots of really, I'd call them very good in the sense of that the person seems sincere doing physics videos, like a professor or something, and he has 300 subscribers. And he's working at a college. And you're just saying even his own students aren't watching his videos. It's just kind of amazing. Let's see. YouTube made some major changes to the channels in 2000 which changed the algorithm forever. Yeah, well, whatever. Hard to say. They make changes all the time. They do shit all the time. They have some new thing now where you have to declare whether you're lying about other people. Whether you're putting up distorted content and fake news and AI content. It's just kind of funny. Yeah, well, it used to be very much you could go to a category, and just watch videos in that category. And you can't even do that now. And then I still don't get the Hindi thing. Like if I search on physics concepts, the search is ruined because they allow a bunch of people actually speaking Hindi to have English titles and to pretend their video is in English when it's not in English. And that should be overtly not allowed, for you to pretend your video's in a language it's not in. That shouldn't happen. So all of the search results are just completely dominated by all these Hindi videos. And it's like, it's not even, you're just saying, why bother trying to search? Because 90% of the search results are all dirt. You have to filter through all this dirt to get to a fucking video. Yeah, that's just a kind of a vague statement, Gilbert, so I just don't know, whatever. They made lots of changes and lots of things. Their policies are always, vaporware. It just disappears. It turns into some new policy. I mean, even the way they broke the whole naming convention of channels. Now people's screen name isn't the same as their commenting name. I mean, it just doesn't make any sense. The Google thing happened so long ago that it's almost not even a subject. And the original YouTube was just to steal copyrighted material, so that was all outed in court. The entire purpose of YouTube was like PayPal. It was a deliberate effort to create a mechanism that would create enough viewers that you could sell the thing for $1 billion. And that was exactly what they were out to do. And they knew the way they could do that was they encouraged people to basically post a bunch of copyrighted material on YouTube. And that would generate a huge amount of viewers. And so the whole thing was just a fucking bullshit. It had nothing to do with YouTubing. It just had to do with stealing copyrighted material and making a big pile of money because you could claim you have 10 million people watching every hour. So that was it. That's what Google bought. And then Google was just a marketing company, frankly. That's what it had become. And so obviously a marketing company is going to find YouTube pretty useful in terms of, targeting advertisement. And so then it became this institution that had to spy on everything and figure out what everything was about to figure out what it could monetize and make money on. So whatever. It's all horrible. There's nothing public interest in any of this. It sucks I can't type massive comments, but I could write a massive essay on how horrible YouTube has become. I don't know. I mean, in a lot of ways it's the same for the last 10 years, but okay, fine. You say it's becoming something. It was always bad, and it's still bad. It was always just a big popularity engine. It was always hard to, get fairly viewed for what subject you were talking about. The spammers and the trolls ruined everything, right? You had response videos as a mechanism, and so you could always see response videos to a video. But it just got spammed. A bunch of people who weren't really responding to the video put videos in the response category, even though they weren't really response videos. So everything gets broken, and the users did as much to ruin YouTube as the corporation did. The users are just trolls and assholes trying to manipulate and break things. And, they did as much damage as the corporate greed. It went from social networking, so again, just bullshit. It was never for social networking, but whatever, to a content delivery service. It was always a content delivery service. It's sad to see its downfall, but there's nothing anyone can do because YouTube doesn't care. Obviously, corporations just care about making money. So, yeah, that's the downside. That we live in a world where we don't publicly finance anything of value. Communication is a valuable thing. It should be publicly financed. And regulated by the Constitution of the United States and the Bill of Rights. I mean, I never got on YouTube to do anything called a social network. Fuck that. Came on the internet to argue. Alright, well, looks like things are winding down. We're down to 10 concurrent viewers. So I guess I will pack it in and such. The internet's a subject, but whatever. Obviously, Google has done more damage to the internet than it's done to YouTube. I mean, the internet is not the internet. It's just the Google net. So all you can get from Google is what Google thinks you need to know. So it's really bad. Search engines, there needs to be a competitive environment. And we need to go back to where you could search for anything and you got honest search results instead of controlled search results. All right. Well, I'm just saying there's a ton of content on YouTube. So you're saying, okay, there's nothing on YouTube worth watching. Well, frankly, it's worth watching Professor Lewin videos, and it's worth watching all of the other science shit. It's all good. So 90% of it is valuable. You just have to be able to filter the part where they're just talking made up wooey nonsense. But there's a ton of good content on YouTube. There's videos of experiments. There's all kinds of stuff that's useful. So it's just stupid to say there's no value here. And if the only value is talking to other people and, saying hi to your friends, that's for you, okay? I'm sorry you find so little value in all of the ton of documentary information on YouTube. There's a ton of it. Okay, and I find it really valuable. And over the last 10 years, I couldn't have done what I did without it. Without the resource and being exposed to all of their arguments, I couldn't have made my arguments. You know, I mean, it's just, I can't even say how valuable it is to go watch different professors teach the same subject and compare them and contrast them and, you know, see what the really important element really is. Gigantically valuable. All right, so with that, you know, backhanded compliment to YouTube. Yeah, we'll end on that. There's still some value. So yes, eventually I guess they'll put it all behind some pay-per-view screen. But for now, there's still a lot of free content that's really socially valuable. All right, anyway, till the next time, and such, and so forth, and whatnot, and blah, 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 and blah, 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 blah. Professor Dave sucks. And it just sucks that sucky people are controlling science on the internet.